Beautiful people, how are you doing? My name is Olwale Godwin and welcome back to Macroeconomics. Now, application of differential application of exponential differentiation in economics. So in our last class we spoke about exponential functions, basically how to differentiate exponential functions in economics. So in this video, this is actually one of two videos for now. So here we'll be introducing ourselves to how to apply exponential differentiation in economics to solve something pretty simple, and in the next video we'll be treating something like in truth more complicated than this, but simple in its own way as well. Let's just get the basic understanding of this, and of course there's an assignment for you in this video. If I forget to leave the assignment here, please remind me, but I won't forget to leave the assignment there. So here we have an exercise which says that we should find the revenue maximizing price and quantity of the demand function below. Show that revenue is maximized. So this is the demand. This is actually an inverse demand function, because a demand function has the quantity as a dependent variable and the price as the independent variable. Of course, price, whatever happens to price will tell us what is happening to quantity, not the reverse. Not quantity changing and price adjusting. If you want to buy something, what do you look at? The price, of course, and that determines the number of the amount that you are going to purchase. Anyway, so if price is the subject, so price is going to be, so the function is an inverse demand function. So let's get to business straight. So we have find the revenue. Basically, revenue is what? Revenue is TR equals the price times the quantity. Okay, and for this, that will be, so you multiply this by Q. So we have equals 12.5 e raised by minus 0. Is it minus 0. Okay, but I was wondering. Minus 0.005 Q, I think. So 12 e raised by minus 0.005 Q. Okay, then everything multiplied by Q. Yeah. So that's the total revenue function. So what we have to do here is, this is a product. This is a product. So it's more or less saying we have 12.5 Q, and then we have e. Okay, let me write it. Let me tell you. Let me write what I'm saying. So you have 12.5 Q. Then we have e raised by minus 0.005 Q. So this is a product, and a product is saying that we take the first one. So this is going to be our U, and the end of this is going to be our V. So the formula is then going to be, so the TR, so this is not dy dx now, so what you are trying to do is the TR dq. Okay, the TR dq is going to be equal to this is product, right? So U dv dq plus V du dq. We are differentiating with respect to Q. Okay, so what is U? U is 12.5 Q. Alright, then the Q, dv dq, so this is V, right? So we have to differentiate with respect to Q. So we're having minus 0.005 Q e raised by minus 0.005 minus 0.005 raised by 0.005 Q. I hope you understand how I got this. So it's more or less saying this multiplied by, what, when you differentiate what you have here. So this multiplied by the differentiation of its power. When you differentiate the power, you have minus 0.005 times E itself. So we are done with the first part. Then plus, what is V? V is E raised by minus 0.005 Q into brackets the U dq, which is 12.5 into bracket 12.5. That's that for that. So what we just have here is 12.5 times 0.005. 12.5 times 0.005. So 12.5 times 0.00 times minus 0.005 basically. So this is going to give us minus 0.0625 e raised by minus 0.005 Q. Okay, then plus 12.5 e raised by minus 0.005 Q. So we collect like terms. This is common, so you can just say minus 0.0625 plus 12.5. No, there should be a Q. Okay, this is Q. And 0.0625 Q plus 12.5. Okay, close the brackets. Then we have E raised to power minus 0.005 q. So to get the quantity, for example, so our quantity in this case is the critical point. So to get the quantity, what we just have to do is to set the TR, the Q, equal to 0. So what we'll be having here then is going to be, okay, let me just do something like this. You have minus 0.0625 Q plus 12.5 equals 0, and then we'll also be having e raised to power minus 0.005 Q equals 0. I already mentioned in the previous class that when you have this, even if the value of Q was 0, e raised to power 0 is not going to equal 0. So there's no value of Q. So Q doesn't have a value that will make this entire function to equal to 0. So we just forget it and we focus on this person. So here we'll be having minus 0.0625 Q equals minus 12.5. So we divide through, first minus cancels minus, then we have Q equals 0.06, no, what am I writing? Q equals 12.5 divided, right, by 0.0625. So let's just do that. So 12.5, I hope you are using a calculator to do this. So Q is equal to 200. Okay, so Q is 200. So that is going to be the revenue. This is not profit. We are just doing a revenue function. So this is going to be a revenue maximizing quantity. Now let us get the price. This is the price, right? So then we just substitute the value of Q into the inverse demand function to get the price. So we have P equals 12.5, right? So E raised to power minus 0.005 into bracket 200. So we'll be having equals 12.5 e raised to power minus 1. So you can try that out. 200 multiplied by 0.005. So we're having, so since it's a minus, we're having the minus 1. And this essentially means 12.5 divided by E. So 12.5 divided by E. 12.5 divided by E. Okay. That gives us 4.59. Let me just verify before we count. 4.60 basically. So that is approximately 4.60. So we've answered the first question that said that requested that we found out that the quantity, revenue maximizing quantity, which is 200, and the price. So what we have to do now is to show that this function is maximized. To show that the function is maximized, we have to do a second derivative of this. So let's just keep this somewhere because I have to rub off the board now. So we have the TR, the Q is this. So we have the TR, the Q. Let's write it somewhere. The TR, the Q equals minus 0.0625 Q plus 12.5, right? So everything multiplied by e raised to power minus 0.005 Q. Okay, so we differentiate that again, and then so we see the value of Q, which is 200, to then see if this revenue function is maximized or not. Let's proceed. So I've written it in this proper form. So what we are trying to do now is d squared TR and the Q squared. So if you look at what we have here, this is basically a product. So we have to use the product rule. Do I have to write the formula again? So just differentiate this. Leave this, differentiate this. So this is okay. This is U. This is V. So we have. I'm just usually forced to write the U, the V, the Q, plus B, the U, the Q. Okay. So U is going to be. Write the whole thing again, minus 0.0625 Q plus 12.5, right, into brackets. This is going to be e raised to power minus 0.005 Q multiplied by minus 0.005 Q. Okay, we are done with that. Okay, plus what is V? V is e raised to power minus 0.005 Q. Then when we differentiate this with respect to Q, we're having q, this is a constant, it disappears, and q disappears, so we have minus 0 point, we have minus 0.0625 left, minus 0.0625 here. So then start to do all of our multiplications. Okay, do we have, so this is more or less okay, but we have this here, we have this, we have from here we could just insert the value of, instead of, let's try to make things simpler though, let's try to make things simpler. So here we'll be having, you can bring this guy here, so we see this is minus 0.005, there is no q here again, yeah, so you differentiate this, minus 0.005, so minus 0.005 into brackets minus 0.0625 q plus 12.5, so e raised to power minus 0.005 q, then plus times minus is minus, so we have a minus 0.0625 into bracket e raised to power minus 0.005 q, yeah. Okay, so we can see that we have, this is common here, this is common, so you can just take the coefficients away, but first we have to multiply what is here. So minus 0.005 multiplied by minus 0.0625, I hope I'm not wrong. Okay, that will give us it's looking somehow to me, so 0.0003125. Okay, you have 0.0003125 q, and then minus 1, 2, 3, 4, yeah, correct, minus 12.5 multiplied by 0.005, 12.5 multiplied by, so this is giving us minus 0.0625 again. Okay, then into bracket e raised to power minus 0.005 q, and minus 0.0625 into bracket e raised to power minus 0.005 q. Okay, so we can just wait, this is this, okay, multiplying this. Okay, so we can just take this and this, so we have 0.0003125 q minus 0.0625, and this is a minus here, so minus 0.0625, and everything into bracket e raised to power minus 0.005 q. Okay, so 0.0003125 q minus this minus, so it's more or less like 2 times, so minus 0.125, so everything into brackets e raised to power minus 0.005 q. So since we got the value of q to be 200, so this is going to be 0.0003125 bracket 200 minus 0.125. Okay, then e raised to power, remember that, okay, let's just say 0.005 into bracket 200 close the bracket. So what does that have to do? So 0.0003125 multiplied by 200, so this is 0.0625 minus 0.125. Okay, then e raised to power minus 1 basically. Okay, then when we do this minus 0.125, so we have minus 0.0625 e raised to power minus 1. So this is essentially minus 0.0625 divided by e. Of course, what we'll be having here is going to be a negative result at the end of the day, divided by so we're having minus 0.023, so it's approximately minus 0.023. So since this answer is, so our display TR, the q squared is lesser than 0. Okay, I think it's lesser sign. Therefore, the revenue function, TR function, is maximized when where Q equals 200. So if this were a firm, so this firm is actually maximizing its output. This firm is actually maximizing its revenue by producing where its quantity is just equal to 200. So if this firm should produce more than 200, it's not going to maximizing it's not going to be maximizing its revenue again. And if it should produce less than 200 revenue, more revenue could still be generated by producing more up till that until keep is 200. So what the assignment now is going to be is, so it's more or less the same question. So you find the revenue maximizing price and quantity of the demand function below. So I'm going to write the demand function out. So you have this demand function to play with. So instead of this, so let me just put it here. I'm done. We are done with this person. So demand function. So the demand function is going to be P equals 8.25e raised per minus 0.02q. So when you are done with it, also show that the revenue is maximized. So this is the assignment. Okay. Assignment. So you can just put the whatever you've obtained as the maximizing quantity in the comment section. Just the value of your quantity and price, and also tell us if if the revenue function is maximized or not, and why. So I was saying that you could gain more from our YouTube channel by enrolling on MOD School of Economics. So if you are interested, there's a certain fee that you have to pay. In fact, it's a monthly fee, and I think it's going to benefit you as a student a lot, because instead of sending the answers, for example, you would have to send all the solutions, and you go through. If there are things that we should tell you, you get to know, and then you are going to have a normal school experience. There's going to be online, so you meet with your colleagues. All right, you have exercises every week, assignments. You have reading materials to go through, then brainstormings, tests, then exams at the end of the month. Okay, so that's the way it runs now. And then we have quiz competitions too, where we have 4 groups. Basically, right now, we have 4 groups for 100 level students. That is first year 1 students, and there is a certain group that is group 4 that has been winning the quiz. So it has won the quiz twice. Yeah, a quiz is today. The quiz is coming up next on the 29th and 30th of this month. So if they happen to win again, that is a legendary feat. And of course, there are prizes for them, and so on and so forth. So those are the things that you're going to get. You get to ask us questions, you get to answer on a personal note now. So it's just like a normal school experience, and would really appreciate if you could enroll on MOD School of Economics. The fee right now, I don't want to say what the fee right now is, because I don't know what year you might be watching this video, and the fee might not be the same. But if you're interested, you can just indicate interest, and then you get added up to the group. Okay, and things starts to flow. So that's that about that. Like I said, I've written the assignment. If you enjoyed this video, click on the like button. For more of our videos, of course, by now or towards the end of the video, that I've seen suggestions that you can watch. So the playlist of this particular video is going to be at the end of the video, so you can watch it from the beginning and just have a nice time. Like I said, in the next video, we'll be talking about another application of exponential differentiation in economics, and it is complex than this. I'm very serious, but it is simple in its own way. Thank you, and continue to stick around. See you next time.
Please like and subscribe.